All right, let's talk about the polar aurorae. You know, the northern and southern lights. They are, without a doubt, one of the most incredible light shows on the planet. But behind all that stunning beauty, there's this one nagging question, a question that kind of pokes a hole in what we think we know about how they work. So let's dig into that unanswered question.
I mean, we've all seen the pictures, right? These shimmering curtains of green and pink and violet light just dancing across the polar skies. For centuries, they've inspired nothing but awe and wonder. It feels magical, like a direct line to the cosmos. But the physics behind that magic, well, that's where we find a really surprising puzzle.
And here it is. Here's the big puzzle. If all those particles that cause the aurora are being pulled toward the magnetic poles, then why isn't the light show happening right at the poles? Why does it always form in these huge rings, these glowing halos, a good distance away from them? That is the central mystery we're exploring today.
Okay, so to really get to the bottom of this, we've got to start with the textbook explanation. You know, the one most of us probably learned in school. It's really the foundation of modern atmospheric science on this topic.
So, the standard story goes something like this. The sun is constantly blasting out this stream of charged particles. We call it the solar wind. Earth's magnetic field acts like a giant shield, and it catches these particles and funnels them down toward the poles. As they zoom into our atmosphere, they crash into atoms of oxygen and nitrogen, and bam, that collision releases energy as light. Seems simple enough, right? Well, the source material for this whole explainer argues it's not quite that simple. While that explanation is a fantastic starting point, it leaves some really crucial questions unanswered. And here's where the source material really starts to pick things apart. It argues the standard view is a bit vague on the mechanics, like why exactly do those particles head for the poles? It definitely doesn't explain the ring shape, which is our big mystery. And even the biggest head-scratcher of all, how does it explain auroras on Venus, a planet that doesn't even have a global magnetic field? This quote from the source really just puts it bluntly. The core problem isn't that the aurora happens, it's where it happens. Figuring out the where is the real key here. So, okay, if the standard model has these gaps, what's the alternative? Well, the source proposes a totally different way of looking at it, a framework built not on magnetism, but on something it calls a charge field. The main idea here is that the Earth is in a constant cycle of recycling charge from the sun. You can almost think of it like a cosmic circuit. Charge flows in at the poles, moves through the planet, and then gets radiated back out from the entire surface. And this slide lays out that cycle perfectly. It's a really simple two-step process. Charge gets pulled in at the poles, and then it radiates back out from everywhere else. So instead of magnetism, this model suggests the aurora is driven by a fundamental electrical engine. All right, so how does this whole charge field idea actually solve our original mystery? You know, the aurora's ring shape. This is the million-dollar question, isn't it? If charge is coming in at the pole and going out everywhere else, what on earth is creating that very specific glowing boundary? The answer, according to this theory, is something called the crossover point. Just imagine two opposing currents, one flowing down from the pole and another one flowing up from the surface of the Earth. It stands to reason there has to be a specific latitude where those two flows are perfectly balanced, where they meet with equal strength. And as the source material puts it, this point of equilibrium, it's not just some theoretical line on a map, it's a zone of incredibly intense energetic interaction. And that energetic clash, that is the aurora. The light show we see isn't happening at the pole itself, but at this crossover boundary. This theory is basically saying the auroral ring is a physical manifestation of this charge equilibrium. You know, a good theory doesn't just solve one problem. It should be able to explain other related things too. So let's put this charge field idea to the test against a few other well-known quirks of the aurora. First up, it's a well-known fact that during really intense solar storms, the auroral rings get bigger. They expand, appearing much further south than they normally do. How does this theory handle that? Well, the explanation is pretty mechanical. A solar storm means a huge increase in the charge coming in from the sun. So to handle all that extra flow, the intake vortex at the pole literally has to get wider. And as that intake area expands, it just naturally pushes the crossover point, the ring, outward to a lower latitude. Make sense?
Okay, next mystery. For over 100 years, scientists have known that auroral activity peaks around the March and September equinoxes. This has always been a pretty complex puzzle to explain. So, What's the charge field's take on it?
According to this source, it's all about the Earth's total charge intake hitting its peak. See, during the equinoxes, even though neither pole is pointed perfectly at the sun, the combined efficiency of charge entering both the north and south poles is at its absolute maximum. More total charge means a stronger interaction, and a stronger interaction means a brighter aurora. And finally, there's this daily cycle. The auroral oval tends to expand to its furthest point from the pole right around local midnight. Why would that happen?
This actually ties back into the last point. At midnight, up in the north, the sun is most directly lined up with the South Pole. This maximizes the amount of charge flowing through the planet from south to north. And that extra internal push widens the northern ring, in pretty much the same way an external solar storm would. So, what we've just walked through is a completely different way of looking at the aurora. Instead of relying on these super complex magnetic field interactions, this charge field model proposes a simpler, more direct mechanical reason for its location, its movement, and its intensity.
And that leaves us with a really fascinating thought to chew on. While the standard model is, of course, the bedrock of auroral science, this alternative view makes you ask a question. In our quest to understand the universe, could we be overlooking simpler, more fundamental mechanics that are hiding in plain sight?